Welcome to the Explainer. Today, we're digging into the researcher's toolkit. We're going to figure out how scientists actually know if something works, like a new health campaign, or how they get a read on what an entire country is thinking. It really all comes down to choosing the right tool for the job, and we're going to focus on the powerful world of quantitative research designs.
Okay, so let's just dive right in with a classic question. You see it all the time. A city launches a big, new anti-smoking campaign, and a few months later, smoking rates are down. Seems simple, right? Well, here's the thing. Proving that the campaign caused that drop is way, way harder than it looks. How do we know for sure it wasn't something else entirely?
You know, in a perfect world, in an ideal lab, a researcher has total control. They can randomly put people into different groups to test one single variable. But we live in the real world, and it is messy. You can't always create those perfect lab conditions, sometimes for practical reasons, and sometimes for really important ethical ones. I mean, you can't ethically force one group of people to smoke and another not to, right? Of course not.
And that is exactly where this researcher's toolkit comes into play. It's not about having one single perfect method that solves everything. It's about having a whole set of smart, specialized designs. Think of each one as a different tool, specifically built to find the most reliable answers you can get, even when you're dealing with those messy, real-world situations.
All right, let's grab our first set of tools from the kit. These are called quasi-experimental designs. The best way to think about them is as almost experiments. They are incredibly powerful when you're trying to figure out cause and effect, but you just can't have that perfectly controlled lab setup.
So this design really gets to the heart of the problem. What researchers do is work with groups that already exist, like two different schools or two different cities. And since you can't randomly assign people to those groups, they aren't true experiments. But, and this is the key, they are the next best thing for finding clues about cause and effect out in the wild.
Now, within this quasi-experimental family, some of the most clever tools are the ones that look for patterns by tracking how things change over a period of time. And this is a brilliant one, the interrupted time series design. So imagine you're tracking something, let's say company sales every month. You get a nice stable trend line. Then you introduce a change, the intervention. Maybe it's a new marketing strategy. After that, you keep measuring. If that trend line suddenly breaks and shoots upward right after your intervention, you've got some pretty strong evidence that your change is what caused it. The time series was interrupted.
So how can you be even more sure? Well, you add a comparison group. This is what we call a multiple time series design. You're tracking two similar groups, say two different stores, but you only roll out the new marketing strategy in one of them. Now, if store A's trend changes but store B's stays exactly the same, you can be way more confident that it was your intervention and not some big economic event that caused that shift.
Okay, but what if you can't track something for months and months? Good question. Don't worry, there's another tool in the toolkit designed for exactly that. It lets you compare existing groups with just a simple before and after look.
This one's called the non-equivalent control group design, and it is super practical. So you take two existing groups, let's say two different high school math classes. You give both a pretest. Then, one class gets a new teaching method. That's your intervention, while the other class just carries on as usual. After a while, you give both a post-test. By comparing how much the scores changed between the two groups, you can get a really good idea of the intervention's effect.
All right, let's switch gears and move to a totally different part of the toolkit. We're going to shift our focus away from cause and effect for a minute and talk about another huge goal in research, just describing what's going on in a large population. This is the world of survey designs.
Basically, anytime you see a news report with a poll about an election, or you hear about market research on what people are buying, you're seeing a survey design at work. The whole idea is to take a small but representative sample of people and use their answers to get a picture of the attitudes and opinions of the entire population.
And survey designs really come in two main flavors. The easiest way to think about it is snapshot versus movie. A cross-sectional design is like taking a single snapshot. You gather information from people at just one point in time. It gives you a fantastic picture of what's happening right now. A longitudinal design, though, that's like making a movie. You follow the exact same group of people and survey them again and again over a long period. Now, following people over time gives you this incredibly rich data about how things change. But, and this is a huge but, the biggest challenge is something called attrition. That's just a fancy word for when participants drop out before the study is over. And this can be a massive problem. I mean, imagine a 20-year study on building wealth. If all the people who aren't doing well financially are the ones who drop out over time, your final results are going to be totally skewed. It'll make your advice look way more successful than it actually was.
Okay, so we've looked at a bunch of different tools now, from the almost experiments to the surveys. With all these options, how do they really stack up? Let's get a quick side-by-side view to make it all clear.
This little table really pulls it all together. You can see right away that those top three, the quasi-experimental designs, are all about nailing down cause and effect. They use time and comparison groups in different ways to do it. And then you see the survey designs at the bottom. Their main job is just description. So which tool a researcher picks, it depends entirely on the question they're trying to answer.
So really, if there's one thing to take away from all this, it's this. There is no single best research design. There's just the right tool for the question you're asking. And understanding which tool a researcher pulled out of the toolkit is always the first step to really understanding and questioning the results of any study you come across.
So we'll leave you with this final thought. The next time you see a headline screaming about a new study, you're now equipped to look a little deeper. You can ask, okay, which tool did they use? Was it a snapshot or a movie? Did they have a comparison group? Understanding the design is how you understand the science. Thanks for joining us.